This conference will now be recorded.
Okay, so let's begin today's session. This is about DevOps demo. In this one, we are going to cover Git, where it is a source code system, and Jenkins, where we are going to build and process with the pipelines, and then our Docker, where you are going to learn about containerization. Then Kubernetes. Kubernetes is a structure where you're going to have orchestration of the Docker containers, and you can make multiple containers to work in a production systems. So it's nothing but a cluster setup where high availability is automatically provided for the containers. Ansible is an automation tool, configuration management tool, which will be useful when you need a continuous deployment on multiple environments. So this is a overall high level overview about DevOps, what we are going to learn. Okay, myself Pavan. So I've done MCA and I have around 15 years of experience in the industry. And I have used to work on middleware technologies, Oracle, WebLogic, and other stuff. And currently working on build engineering and release services, where we are working on continuous integration tools such as Jenkins and Hudson. And we are working on automations as well, which includes Python basic programming, and it also uses the different continuous integration tools. Ansible is one of the tool which we can use in our course. So this course is basically, I feel, it's a high level fundamental or overview kind of thing, but it has a lot of depth for learning the DevOps. So in this session, I'm just give you a history of this evolution of DevOps, how it came, and then we try to understand why we need this DevOps, what is the importance of the DevOps, then what is that actually DevOps means, then DevOps tools, what are the tools in the current market, and what we are going to cover. After that, what is not DevOps? Sometimes you might be feel confused while working initial state, then you could feel this is not DevOps. So you should be clarified so that you can work on the DevOps properly. So what we can cover in this course, I just give high level overview in this session, but I'm not having the complete content exactly. This is what that is not yet clarified. So I just give you what is the scope of DevOps and how you can work on, right? So moving on, so evolution of DevOps. There are a lot of software development companies which followed since so many years, and they're ready with the waterfall model. So waterfall methodology, it's based on sequential steps. It starts at one place where the client requirements will be collected, and after that it will be processed, analyzed, and then that will be goes to the design phase. After design phase approved from the client, then we are going to work on the implementation phase, where the coding part will start, and in installation configurations POCs will work. After that it will go for the regular setup, complete configuration. Then we will move on to the testing phases. The functionality is working or not. After testing, the actual implementation will go to the production. So this is how the real-time, the old system or existing systems, huge systems which are running, they are following waterfall methodology. So this one phase to another phase changing, it takes a longer time, The waterfall model is very good, but it is having the tenure, longer tenure. So that is the biggest disadvantage they found since so many years they are following. So once this system is under development, you can define upfront what are the changes you want to give or what are the features you want to add for your new environments or for your product. Okay. So once a phase completes, there was no option to go back to the previous phase. It has to complete all the phases, what I told just now, all the phases, then only it will come back to the initial state, again getting the requirement phase. So that is a disadvantage in the waterfall model. After that, there is another methodology in the software development that is called lean methodology. It is developed by Toyota, the car industry. They introduced this technology in 1990s. So everything in this model, in lean model, every employee who are working for the Toyota, they are used to work small task day to day, and they have to achieve a goal, and they are defined as small goals, and they are keep on improving one particular goal. So it is not, let's say you have a goal to reach one particular feature improvement. It is car industry. So they want to improve the speed of the car, let us say. They want to focus on this one and they start the engine developer, the employee who is working at the tires, they will think in a different mode. The person who is working in the building the body, they think in a different mode. So each one think in a different mode, and they are introducing their own new additions, new features into their works, so that collectively they are going to have one common object. Okay, so that will work in mechanical industry, and the this methodology was introduced to remove unnecessary options. So when you are going to have lot of options, as we see in the cars, there are a lot of models. Each model is having different benefits. But when you compare one with another one, something will be you feel unnecessary, useless. So these unnecessary things are keep on removing so that to get the best out of the old one. So that is a lean methodology, and it is adapted to IT, and they also shared with across the IT industry. Okay, so when we use this lean methodology, and it is adapted across the software features, some of the communication, the software features are improved, and communication delays, slow application response times also improve. Okay, so the last, which is what we are focused, that DevOps is focused, is the agile methodology. Coming from these two different methodologies, waterfall model, lean methodology, there are a lot of other methodologies each company follows. They mix and change the technologies, methodologies, improving their software development lifecycle. So this agile methodology is completely different. It is learned from the previous methodologies. So agile software development lifecycle model is a combination of iterative. So every phase that in waterfall you cannot go immediately. So in agile, at any phase you can go back and change. If some model is change, you need change, or design is not acceptable, then you need to go back and redesign it. And every component, every feature is distributed very small pieces, and each piece you can redesign. And lean methodology, this is small first and then go move. So that's for it is not a huge thing. So if something goes wrong, only one small piece will be affected. That is what focused in the agile methodology. The process of adaptability, the customer satisfaction is most important in the agile methodology. Amazon follows agile methodology. The world's biggest successful softwares follows agile methodology, and it is very rapid to deliver. If you compare with the waterfall, it takes 6 months to deliver some new feature. Whereas in agile methodology, the tenure, the time duration, it will be 2 weeks. Within 2 weeks, they are going to get the new feature. So that is what a rapid, very speed developments are expected from the agile methodology. If something not working or it is not enhancing, then they skip this, suspend that feature in the agile, and they can move on to other improvement phases or other pieces. So that is how this agile methodology works. So it actually breaks the product into small incremental builds. Let's say you have the front end, you have the UI, that part is different. You have the middleware components are completely different. They are built separately and delivered separately. So these builds are providing iterations. You can do multiple. If you see the Amazon example, in a day they are going to deploy 200 to 300 times the entire application. They are building and deploying. So this agile methodology is supporting that one so much fast they can do the deployment. To make that one, how that is possible, that is what DevOps. So here is what we have the opportunity to learn how to make things so faster, and what is missing in the waterfall, what is missing in the lean methodology, that two are included in the agile. So when you are working on agile, agility is actually defined for betterment of the employees who are working for the software development. So there are two sides. One is development, another one is operations. Previously, it is two different teams, or there are two different people set, or managers will be different. So this agile methodology mixed with the both, and there is no barrier. Anyone can develop, anyone can work on operations. So this makes collaborative working, where the operations team are not able to match the speed of the agile methodology to facilitate the provisioning of the servers or deployments, rollbacks. This is normally when we are working on the real-time production systems. In production systems, you are going to have some thousands of servers running. So in that case, how do we work so fast? As we see, number of deployments, you need increment. How to make that speed? That is, if you know the development, if you write the infrastructure as a code, then you can make this possible. So that agile methodology is coming from the development to the operations. Operation teams feels that it is very difficult to bring that speed, but when you learn DevOps, when you learn this methodology, then that will goes back. Okay, so agile is our main culture which used in the DevOps. Okay, so why DevOps is important? The first point is fastest delivery, faster to market. So when one product comes for e-commerce, who is going to deliver on the website? They are the king, they are the best sellers, they are the top. So first thing, we need to bring that the customers in focus. So first time you are going to focus how to bring that one to your website. Okay. The second thing is lowest cost to deliver. What is the best method to bring this software to deliver? So whatever you are developing, the developers are developing, that could should cost very less. So how we can make that cost very less? One solution, using the cloud. The another method, how you are using the resources. Okay, cloud is fine, but what cloud I have to use? I have to think about so many things. So you need to check all the possible ways, which is the best one, and you have to choose, right? So when you are going to work on the lowest cost, even though you are working on a on-premises data center, what are the system requirements? How many servers you can run in one server? Are you really using all of the system resources properly? That you need to able to estimate or calculate the capacities of your systems. Okay, then the next point is about no vendor lock-in. When you're working on DevOps, you should not get a hassle. Let's say I'm going to use a WebLogic, I should get a license. I am using Oracle database, I need to get the license. If I'm working on a IBM DB2, then I should get a license. So this vendor lock-in is a big challenge. Sometimes it is going, license will be expired. Again, you need to work on that one. Okay, so they actually gives the support, but the last couple of years, people are focused on open source systems, containerized systems. You just don't want to think about what is inside. We just want to put the developed code. So that is what we want. The developer want no vendor lock-in, so that they can focus on the new features into their customers' requirements. Okay, high quality and few bugs. Agile methodology, DevOps, provides this high quality and few bugs. The number of bugs, number of missings will be very less when you're working on DevOps, because everything is smaller. If you are having the software program is huge, 200 lines, then you will be finding some issues in that 200 lines. If you compare with the 10 lines code, the 10 lines code will have less bugs, obviously. So that's why everything is broken into small pieces. Okay, that's why the quality is better in DevOps. Multi-cloud support. In the current market, you have seen so many clouds into the market: AWS, Azure, Oracle, IBM, Bluemix, Ocean, Digital Ocean, HP Cloud. There are multiple clouds available, and every cloud is having different capabilities, different advantages you will be getting. Some of the clouds providing infrastructure, some of the clouds providing platform, some of the clouds providing software as a service. We'll see that in the next sessions when we discuss more clear on the types of clouds. Okay, so when you are working on the DevOps, so why we need DevOps? These are the key points. Fastest time to market, lowest cost for the delivery, no vendor lock-in, higher quality and few bugs, multi-cloud support. You can have today the product, your developed software that is running on Azure. Tomorrow it may be your AWS given some offers. You can shift that entire development software onto AWS. That is supported in DevOps. That is what multi-cloud structure. So you don't discover any software. you are working on existing software that will be working faster. That is what the advantage you are going to get from the DevOps. So until the late in the life cycle, or worse in the production. So what we are going to get, the outcome, the final, it goes to the end, that is production systems. So you are working on agile, that is going to give the speed in the development, but any gains evaporate once the application goes into production. So if that goes to the production, nothing you can change. So that is the same thing as in any other methods. Your developers are testers, the quality assurance team, QA team, constantly waiting to access the URLs, resources, and they want to work on the testing on them, and they are going to give some causing delays. Why it is slow, where it is slow. So you need to think about that, and you need to work on that issues. You cannot pinpoint problems across development, testing, production, operations, because everybody part of DevOps team. It's a collaborative work, and everyone part of the DevOps team. You see simple human errors wreaking havoc during the development and deployment. Developer develops, there could be some mistake in the code. Deployment process, some steps you miss, something goes wrong in the deployment. So these are common when you're working on the manually. So this, if you make automate, that is what DevOps. Development views their jobs. Development views their jobs, what is happening, that you can see, you can monitor what is happening. Is it build successful or fail, that you can watch. As finished once that application in the developer machine, that can move on to the testing phase automatically, and that tested output will comes automatically when you're working on DevOps. Once that is successful, then that push to the production systems. Okay, so anytime a problem arises, that may be development phase, or that may be in testing phase, that may be in um, moving to the functional test or UAT or some other test. Any time if some issues raises, everyone starts pointing one to another, finger pointing. This is common in previous methods or older methodologies, waterfall model or any other methods, different methods. So that is gives that comes to a name blame game. So that will be automatically dissolved when you work with the DevOps, because everyone in the same team. There is no other team, only one team. Development and operations both are in the same. So this will resolve name blame game. Okay, right?
Excuse me.
Yeah,
Yeah, I have some doubt. Sorry to disturb you.
yeah,
Uh,
sure, definitely. It's an interactive. You can ask any question. Yeah,
yeah. So, are we going to do these deployments in production as well using this DevOps?
yes,
Or
definitely.
only the
That
environments?
could work. That is what in real time happening now, and since 2013 onwards, the containerization and orchestration gives a complete support for the production setup.
Okay. So, if something goes wrong and if some error comes, so are we going to roll back it on the DevOps only?
Yes, everything will be work from the DevOps. I think still we are not at come to the what is DevOps. So
Okay.
DevOps it's a concept. It's not something one thing and that is going to work, right? So
Okay.
it's not a product. DevOps is not a product. DevOps is not something where you can just click the button and it will go forward and backward. It's not like that. It's a technology. It's a concept. Yeah. So still you have something to ask before going?
No, no. My ask was just if something goes wrong, so are
Uh-huh.
we able to roll it back using the DevOps only, or do we need to do it manually?
That actually depends on how your infrastructure is based or built. If everything is
Okay.
placed in place, then definitely it will be done from the DevOps only.
Okay.
Yeah.
Thank
Right. So DevOps is not a one single product. What I'm saying in the beginning, we are going to learn about Git and Jenkins, and then we are saying Docker, Kubernetes, where it is going to be works. All these comes as a product or something. No, all are different open source technologies. They are not one particular technology, and they are not only these technologies you have to use. If you take containerization, Docker is famous current market, top number one containerization technology, but there are so many other containers also available. Rocket is another container technology. If you see Kubernetes, that is orchestration of the containers, but there is another set of orchestration tool, Docker Swarm, that is also okay. So there are different technologies will be used in the DevOps, and it's just a methodology, implementation of agile methodology that unites the often separates what we are going to call software development and production, what you are going to say operations. It is into single team, single collaborative work where it is going to integrate and it is going to deliver the continuous process. As I mentioned, in a day they are going to deploy 200 to 300 times. You can think how matured that system in the DevOps. Everything is on place, then they are doing so many deployments. Okay, so that is how this DevOps culture is developing. So development plus operations together forming a DevOps teams, and DevOps we are going to have a lot of opportunities in this. There are different phases, different areas, and the job titles also coming as a DevOps engineer, and SRE is a common name right now people are using. Site reliability engineer. Okay, so DevOps who are learning, they can go and look into the SRE jobs. They can explore those areas. And DevOps end to end, if you know how that is deployed for one project, they are going to call DevOps architects. DevOps, it is about breaking down the barriers between the development and operations. How to break, how to mix. That is what DevOps. It is a leverage of peoples and processes and technologies to get what you're going to get. The end is a cost effective, less cost or lowest system resources you're going to use. Okay, so the collaboration work and innovative thinking is always encouraged in the DevOps. It is across all entire software development, and it is release the process. We are going to have the one particular build that we are going to call as a release 1.10, that is a release version. The next one 1.20 is the next version. Like that, you're going to have number of releases that is supported from your DevOps. DevOps, the system which is must act as a feel like a they are going to have one single team. That is a main motto of the DevOps. Okay, so how this we are going to achieve DevOps? DevOps, it's a culture. So if you think, then you're going to code. Then once you develop the code, that may be just, I'll just give one example. I want to create one server that maybe runs on one platform. So I should have everything written in file. So let's say I want a Linux, Red Hat Linux, and in Red Hat Linux, I'm going to run a server, a service. I want a service that should be exposed. So this may be written in Java, this may be written in a C Sharp or .NET, something. So that will be a code again. And this will be delivered as a service. And then it will be run. So once it is running, you are going to manage or test, provide the QA to this application. You can access, you can test it, all the functionalities working or not. Everything going good, monitoring will be continuously done in the production systems. So this entire step-by-step process, if you know, if you're aware, this all parts, any part you are able to link up one to another, then you are in the DevOps culture. Okay, so DevOps can be broadly achieved in the below phases. The first phase we are going to call collaborative development. So when you're going to think about something, you're going to design, you're going to write all the algorithms, and then you're going to make the code. That was the old fashion. Right now, think code. This is the shortest way, and it is required for everyone, not for the administrators, not for the operations, not for the developers. It is for everyone, the same phase you have to follow. The second phase is continuous testing. You are developing a feature and you are testing, but the next phase you want to test for the high availability. This is going to work with the 10 users also. Is that feature, the application what you are using, is it going to work with the 1,000 users? Like that, it will be tested with the stress test and with the load also. So that will be happen for every feature the developer developing. Okay, so that is the second phase. Then third phase, continuous integration. I am developing a feature, and another developer working on B feature, another developer is working on C feature. So all these three I want to integrate continuously. All this goes into one Java program. Let's say all the three changes, A, B, C changes, will go into one single Java program that is supported in DevOps, that is supported in collaborative working. They are different tools. So in previously we have the source control systems. Now this same source control system that supports this collaborative working. So everyone working on small pieces of the same program, and they can merge and they can deliver after the integrating. So this is possible with the GitHub or GitLab or Gitbucket. These are the different software supports this continuous integration of the code. Continuous delivery and deployment. So when you're working on this code development, then it will be deployed on one of the internal server. It may be going to a Tomcat server, it may be going to WebLogic server, it may be going to some other server. So when this server deploys or runs that deliverable, that deployable application, it is continuously developed. So I'm developing a feature I delivered today morning 9 o'clock, and another B feature is developed at 12 o'clock, that is again delivered. So like that, the C feature is also developed in the same day but in a different time, that is supported in the DevOps. So it is continuous delivery, and that code that will be what you are sharing, that will be collected, that will be extracted from the Git, and that when you are completing, you are going to store this code, the deployable thing into Artifactory. So there are different tools supports this Artifactories, and that continuous delivery deployment will be supported on that. Okay, the continuous monitoring, when you're deploying this, it may be going as a container, Docker container, or it may be only just a war file or jar file. Once that deployed, then what is happening to that application? Is it running successfully or it is going fall? If it is fails, then this monitoring system automatically alerts and you can revert back or roll back. Okay, so that is possible. Continuous monitoring helps to do that. Okay, so this is how the DevOps works. So what is DevOps? Includes the collaborative work. That what is the first phase what we have seen. The first phase, the collaborative work, the code. If you are going to work on the different development tools, Java programming or C Sharp or different technologies, Python, anything. So yeah, if you are working on the agile methodology where you're going to develop the software and you're going to build, uh, the focus is based on the business and it is going to make that code develop and build fast. So this build is done by Maven, and once this code is written, your code will be distributed across multiple developers, and that will be controlled from the Git server. Okay, so Git is one of the best source control system that will provide collaborative development. Same code will be used. Let's say I have e-commerce website code. I am developing one feature. That feature will be part of my system. I just downloaded my entire e-commerce site web, software into my system, and that is local to me. And once I have changed, that will be pushed, that will be committed to the local of my Git. So it maintains, Git is such a nice software. It maintains the source so well, and it will be help the multiple developers to develop the code and better control on the entire system. If one server goes down or something worse, or you don't have the internet or connectivity network, still you can work when you are working on the Git. Whereas in other source control systems, you don't have that facility. Anyway, we will discuss very detailed when you're working on the Git and other stuff. Okay, so predictability and support and the changing of the requirements. Every requirement doesn't accomplished within one phase or one time. You have keep on changing continuously to complete your project. Okay, so Git supports that, and Maven is used for building. Okay, and Maven is also supports the continuous testing as well. Once your build is completed, that will be automatically deployed using the Maven plugins. This is just one example for the Java based application. So there are other plugins also supported in the Maven. You can also develop C Sharp or Python based codes as well. But anyway, we are not very focused on the development part. We are focused on development operations, DevOps part, how that is going to work. Okay, so DevOps cannot be realized without continuous testing. So because whenever you build, it is automatically tests. So what need to be tested, you need to define that one, how what are the parameters you need to include to test. If that parameters are given, then what is expected. So if you define that one, then it is going to execute automatically. If you cannot define that one, that will be again go to the manual testing. Okay, so there are now the test functional testing is moved to different phases. Mobile testing is different, and UI test is different. So that will be accomplished between with the different tools, automation tools. Yeah. Any questions? Moving on. Okay, so what is this continuous integration? How that is going to work? As I mentioned, we are going to create containers, the Docker containers. The focus is once I develop a code, the feature is working for me, the same thing should work for the others as well. That is the main reason for creating the containers. Okay, so you don't want to go with the different deployments. Again, code will be changing. That is old way of working. So DevOps supports a containerization. DevOps follows that. It is going to tell that continuous integration. You can integrate with anything. You can connect with different services together, and you are going to start working on one new feature, and that should not be impacting others. It is completely isolated, and when you complete your work and it will delivered, that is completed work is going to work as a, it is going to collaborate with others work as well, and it is going to take everything together and then move on to create a new containers. So that is how the main problem, the old problem is resolved. So earlier it is to fix some changes, they have to wait for a longer time. But here, if fix is ready, then just create the container, replace the container, finish. The container, Docker container will resolve, just you replace the container. Okay, so there are multiple methodologies to implement, but DevOps uses the agile methodology that is so practical, where it's focused on integration with the different tools to give best quality. When you're going to get best quality, it is tested so many times. So when it is tested, when product is coming well, so whenever you have something designed, that design build is tested, then it is delivered, it is shared. This is the simple 4-step phenomena uses in DevOps continuous integration. Okay, so in the continuous delivery and deployment, there are different tools in the market. Okay, so in this DevOps CI CD or CD part, deployment part, the build part is coming from the pipelines. The pipelines are supporting, are used as a code. You can write anything, any technology you can use, but Jenkins is a common open source. Okay, so it is supporting a rapid safely deployment pipeline which you can develop, and it will deliver to artifacts. So it is going to make end. It may be a container, it may be a jar or war file. So that will be delivered as a end deployable component, deployment unit. So this production like environment setup, you can ensure that business applications and the services functions as expected through rigorous automated testing. So this testing will be done. One pipeline will be built, another pipeline will be deployed. After that, test will be done. So these pipelines will be having different jobs, different stages, different phases. It is going to take part, and then it is going to finish that stages. Okay, once that is done, you can say confidently this application 100% quality assured. You can deploy this one to a production, you can push this to production. So that is assured by the DevOps. Okay, so it is primarily the CI/CD process or CD process enable. The goal is to automate everything. Deployment is deployable product will be very fast, and it is interconnected with the other steps, the stages. So if you take one example, you are going to deploy into Tomcat. So what do you need? You are going to write Java program, a web application you are writing. It may be Servlet or JSP. That is going to create a WAR file. This war file every time changing. The Tomcat is same. So the deployable deployment unit is the war file. This war file is ready or prepared, built by the continuous integration tool. You can use any tool. Jenkins is going to support this extracting the code from the source, that Git or SVN. So you selected the Git as a source code. You are selecting or getting the code after that compilation and build. That is, you're going to create the war file. So this war file is created using Maven or Ant or something. After that tool executed, then the pipeline gives that it should go to Tomcat. It is deployed. So Tomcat is able to display what we want as UI change or web application change. So that is when that war file is in present in the web app folder, then application is working. Once that is working, then you can test what has changed. You just give the parameters to inputs that is working on this web page or not. That will be tested from one testing tool. It may be Selenium, it may be some other tool. So this test is successful. Again, Jenkins got the result and it will says that finally this is available for production. Okay, so this is how the CI/CD process will be supported from the continuous integration tools. Any questions? No? Okay, so sometimes continuous deployment is referred as continuous delivery. CD, just say CD. So Bamboo is also one of the tool, and Hudson is also one of the tool. So these tools are supporting CD. So the only difference between this CD or CI/CD, whatever the name you are going to say, but the focus is continuous deployment. So it is usually refers to production deployments. So the end part is always focused on the production deployment. So production, we in development phase we can run 10 times. In production, when it is going, only one time it has to target. So when it is going to target, there is in between you are going to follow all the quality assured testings should be done. Okay, so moving on. Yeah, continuous delivery, continuous deployment, how this is going to take place, what is this pipeline, how that works, right? So unit testing, platform testing, deliver to staging, application acceptance test, we are going to call in short UAT, right? So deployment to production, this is completely manual previously. Yeah, continuous delivery means it is manual, but post deployment test, that is automated. So this continuous delivery means you have a set of phases, and if you see continuous deployment in production also, deployment to the production is also automated. So there is no manual intervention. That is a only difference you can see between the continuous delivery and continuous deployment. There are businesses, different cases where we are going to test the IT team. Everyone is working on new features. So they are going live. When it is going to get that live in continuous delivery, you don't know, because there is a manual intervention. But in continuous deployment, you are going to say 100%. This will be available after 2 o'clock. Or like that, you can mention you are ensured your time when it is available. Okay, so that is a difference between continuous delivery and continuous deployment. Okay, yeah, so when we are working on this DevOps, continuous monitoring is one of the phase. So this is actually available, that is you will be testing monitoring on every phase, or development phase, or QA phase, or staging phase, or you're going to say production phase, continuous monitoring is always preferable used. Okay, so when you're working on DevOps, this is last phase, what we are going to say monitoring. Everything is developed, code is running, testing, going to the production, then it is under monitoring control. Okay, so DevOps will take complete all the phases like plan, code, build, test, release, deploy, operate. So these 6 phases will be used in the DevOps. In the 6 phases, 5 phases are into continuous delivery. Plan, code, build, test, and release under continuous delivery. And continuous integration, plan and code and build and test. These 4 phases are continuous integration part. And if you look at agile development, I'm just saying development, it is just up to the build, plan, code, build. So very, very short 3 phases you are going to see in agile development. Okay, then the entire all these 6 phases are 7 phases, what you are seeing, that is completely collaborative. All the teams, all the different technologies where people are going to work there. Okay, so somebody knows very good servers, Linux, somebody knows very good Java programming, still the team will exist and they will work collaboratively. Okay, one feature is required, the Linux administrator who already work, and he is going to ask something I want, can you make this? So that is development team takes up and help him to get that achieved. Same way, opposite. So some features needed, the memory is required, and administrator helps them to increase or decrease. These are the collaborative phases where each one in the development team will work collaboratively. The final life cycle of DevOps works with these operations. That is continuously working in a production. That is what our aim. Okay. So when looking into the tools, what are the tools we have? There are a lot of plenty of tools available in the current market. You don't need to worry what you have to choose, which one is, that will be burden of the customer who is thinking about implementing the DevOps, and they are going to have architect, they are going to think about all those. So at the moment we are just learning DevOps, so you just aware of these things, that is enough. Okay, so source control code you are writing, that will be stored into Git or SVN or Jira. Then the code will be build. There is a set of build tools. Continuously you want to create 10 jars or 50 jars, then Ant or Maven or Gradle will help you to build the jars or vars or any deployable units. Once the deployment unit is ready, then you're going to deploy it, right? Once it is deployed to servers, Tomcat or WebLogic or something, then the application will be tested. For that, we have Selenium or JUnit. These are the tools. You don't need to worry about, do I need to work on this? You just need to think about these are the tools, just have the awareness of that. On the other side of integration, your integration will be taken care by Jenkins. This is not only one tool again. Jenkins can be replaced with Bamboo. Jenkins can be replaced with Hudson. Then on the right side, if you look at deployment tools, configuration management tools, we have Puppet, Chef, Saltac, Ansible. Any one of them do the same thing. Any tool you to take, it will work for the same kind of work. Okay, so which is the latest one? That is Ansible. Which is the oldest one, so matured? That is Puppet. So that depends on the company, they are going to select this one. Okay. Then operate, when you're working on the production system, how that will be monitored. After going to the production, only thing left is monitoring. So monitoring can be done from the New Relic or Sensu or Nagios. Now again, new stack came, ELK, Elasticsearch, and Kibana is another set we are having now. Another one new set is Prometheus, Grafana, also there. They are different monitoring tools, open source monitoring tools. If you take New Relic, Nagios, Sensu, these are all proprietary. You need to pay for the license. If you are running more than 10 servers, you cannot work with these tools. You need to buy the license, then only you can work. All right, so moving on, these are the tools. What is not DevOps, right? So DevOps is not unholy union of development and operations team. Is it merge, or is it something you are going to say, you are saying development and operations into one team? Is it going to work? So it is based on the methodology, and it is based on the thought process, how the agile process implemented. So how they are going to maintain the agile dashboard. Accordingly, we are going to work on the Jira tickets. So these tickets can be defined by the Scrum Master, and then that will be estimated. And each task will be estimated with some number of hours, estimated with the cost, the time that's spent by the developer or the DevOps engineer. So it is not one person, anyone can take one particular task. Let's say Melvin taken one task, he started working, and after 2 hours, he didn't complete it. That can be assigned to Pawan, and Pawan can continue that. But the task should be completed within that 1 week or 2 weeks, whatever the time is assigned. Okay, so it is a collaborative work, and it is not just merging of the teams. DevOps only exists in cloud, is it? No. DevOps, you can work on premise also, or data centers also. Okay, it's just a culture. It's just a methodology implementing with agile. DevOps is a single product. No, it is not a single product. You can use anything. You can use Docker, you can use Kubernetes, you can use Docker Swarm. It is not necessary this is only DevOps. There is nothing like that. There is no software called DevOps. DevOps in not a myth. DevOps does not mean that developers are responsible for ops. There is no link. There is no overload on any employee or any DevOps engineer. So it is equally distributed, everyone collaboratively working. DevOps does not mean that governance and compliance must fall by wayside. So you should not see, I don't need to write something compliance tests or something which is required by any software companies. You have to follow all of them, security and whatever the rules are provided, you need to follow all those, and then this development will continue. For example, you are working on a banking project or financial product. They have their own restricted rules. You need to follow them. You need to get trained on them, and then only you have to work on those. Okay, so the governance and compliance must fall by the wayside. Any questions? No. The scope of DevOps, the DevOps is not a software, as you know. So we are going to learn a couple of softwares out of the DevOps, what we have current industry is using. Okay, so we have very wide range of softwares, set of softwares. They are called as DevOps tools. But DevOps is going to be de facto standard for the software development lifecycle. Okay, and gaining the knowledge on the complete infrastructure the development lifecycle, that is very important to work on DevOps. If you don't understand what is software development, then you cannot work on the DevOps. End to end, if you have some idea how the software product will be built, how that is coming to the life, if you understand, then you can work on DevOps tools. Early advantage in DevOps can be helpful to grow faster in industry. If you know latest trending softwares, just now I told in the monitoring, there is a Prometheus, Grafana, and Alert Manager. These are the latest trending monitoring tools. They are open source. So if you look at those softwares, it will be very fast. It will help you to grow you faster in the industry. Higher earnings you can get from the DevOps because right now market complete jobs shifted from the administrator jobs to ops, completely DevOps. Okay, so this is the scope of DevOps. What is DevOps? Anything you have to ask or question for me on DevOps? So I'm going to cover in this DevOps Git, and I'm going to cover Jenkins, continuous integration, pipelines, and Docker. In the Docker, we're going to learn about how the Docker containers will be created, how we can install, configure Docker infrastructure. Once that containers are created, how we can test, how we can make a web application, put into that Docker container and test it, that part. And then we try to run multiple containers. One container talk to another container. This is what real-time requirement, right? So containers are actually supporting microservices. We are going to use that microservices containers into a clustered environment that we are going to call as Kubernetes. So Kubernetes is the next thing which we are going to learn. After Kubernetes, will work on Ansible. So these are the 5 tools which I focused in this course: Git, Jenkins, Docker, Kubernetes, Ansible. Any questions?
So you are going to cover up.
Yeah.
So you're going to cover up all those things which you just said now in the
Yeah.
later part. Okay.
Yes.
Okay.
Melvin, are you with me? How you are feeling? Is it fine for you, or you want some more?
No, it's good for me.
Okay.
It's
Yeah, it's
great.
absolutely a good.
Okay, thank you. So let's
Yeah.
meet tomorrow at the same time, and we can have more details in the DevOps and further learnings. So this time is fine, right? 7:40 a.m. IST.
Yeah.
Yeah. Okay. So Vaishnavi, could you please also share with your friends, anyone, if somebody also want to join, then it would be much more happier for me to.
Yeah, sure.
Yes.
Sure. And
Okay,
it was a
Melvin.
good session too.
Yeah. Thank you.
Yes. Very good.
Thank you, guys. Bye bye.
Okay. Thank you.